These guys have been doing it for a long time. They're going to talk to us about the digital reality ecosystem that they are building at ExxonMobil. Welcome them to the stage. Kyle Daughtry, the digital reality strategy manager, and M, the 3D architect.
Hey everybody, can you hear me? Yeah, all right, real well. Based out of Houston, Texas. The question was where we're based out of. Yeah, we're in Spring, like a little bit north of Houston area. We got a big campus out there at Exxon. All right, cool. Microphone over here. You take that one.
All right.
All right, can you hear us now too? Both of us. Good to go.
Cool. Good morning, Dallas. Good morning, AES. How are y'all doing today? Awesome. This is a big crowd, great turnout. Thanks for showing up. Move into a visual way of working. Just remember those words, because hopefully by the end of the presentation, you'll understand the vision for the Digital Reality Ecosystem Project by ExxonMobil. My name is M. I've been 20 years with the company, and I'm the architect.
Hey, everybody. My name's Kyle Daughtry. People call me Kyle. I've been with Exxon about 18 years across a bunch of different technical and digital roles. Myself and M have been together working efforts in this space for probably the past 10 years or so we've got pretty good relationships together. I am the digital reality strategy manager for this effort that we're calling DRE. So, going to spend a little bit of time talking to you about an agenda, super fast. There's probably a lot of folks that have seen or heard what we're working on in terms of DRE, but we did want to give an overview for the folks that are in the room that haven't. Give a little bit of our aspect of flavor of what we're calling layers of spatial data. Some of the use cases, give you some visuals, to tangibility things to what we're actually doing. Our aspect of reality first, I'll save that for what we mean by that. And then a call to action. That's probably the biggest thing for us is come together as an industry to solve big problems.
All right, let's get started. It's about 10 years of research, 3 years on the project. You guys will be drinking from the fire hose. We're gonna slow down in the beginning, and we're gonna start picking up the pace once you guys understand what we're doing with our data. But let's focus first, because there's about 255 definitions of a digital twin, according to a military white paper. So we wanted to share internally how we've been shaping those components for ExxonMobil. These are really the three things that we really care about. It's the visualization, the data aggregation piece, followed by the analysis, simulation, and modeling, right? So a good analogy is Google Maps. The road is the visualization. The data aggregation would be the traffic flows, the red light cameras, the cops on the road, and so forth. The prediction piece, I need to get the Hyatt Regency from the Marriott or whatever in Houston, and it takes me about 3.5 hours to get over here this morning. So hopefully that's a good example, and at the same time, I want to focus you on this capabilities periodic table as well. We adopted this from the Digital Twin Consortium, and it's really helped us to understand exactly just the breadth and the landscape of all the capabilities within the Digital Twin platform. We urge you guys to take a look at that as well further down the line. We'll share a link, but just wanted to, hopefully you guys understand what components really matter to ExxonMobil, and there's a lot out there.
We'll talk about that towards the end about the capability model, and we have zero desire to introduce a 256th. Right, the whole model here is how do we actually access data and information across this whole spectrum, which kind of leads into this aspect of efforts inside of our company to be able to build data products that are scalable. So scale is the whole game for us on pretty much everything that we're doing now, and it goes a lot further beyond the aspect of how do I get a headset into somebody's hand or leverage that for training or use it for design or whatever it would potentially be. It is about creating scalable data products in each of these particular spaces. So on the first side, there's a lot of work efforts inside of the company in creating a master truth of all of our engineering data, inspection data, you name it, equipment data, in this effort that's called EDP. And that's a work effort with a sister group inside of our organization. There's also a big work effort inside of Exxon and how do we take our documents and drawings and move those to data components. So no longer do I have to manage a file for a particular drawing or a P&ID. I can manage it as data. Today, the main thing we're talking about in this whole journey is how we're creating the ground truth of spatial and visual data. All of these tie together. There's a tie across each one of these aspects. But we'll talk a little bit more about that in a second.
So what is DRE? What is the digital reality ecosystem? Why an ecosystem? It really comes down to what Kyle was talking about and how we alluded towards it, right? It's a data play. You got to make sure we have an ecosystem of data coming in that's open and interoperable. Look at those big words on the third bullet point. Modular, open, agnostic, standards. We did the total opposite. We were closed. We were locked in. Our data was not free. So naturally, well, we pivoted. Said, we probably need an ecosystem. We need to own that data so that way we are free from all those handcuffs that we need. The picture down here is really how what Kyle was talking about, that spatial data, how we layer it from the physical all the way to the virtual world. And then from there, that allows us to give us a specialized view or a holistic view of our data.
All right, so Em mentioned this aspect of open and interoperable, so I won't badger that, but that is the name of the game, scale and being able to use our data at any point in time, anywhere. But another big component of this was us breaking apart these pillars. We call them pillars of capture, store, deliver, and consumption of information across that aspect of the digital twin and XR and every particular area, training, design, all of it. And I'll focus just a little bit on the left-hand side on the capture part of it. One of our biggest goals is to democratize that capture. So allow our folks to bring in more self-capturing devices, but also give the right guidance and guardrails to all of our engineering service companies that are actually doing work for us at scale. There's a lot of work that goes into that. There's a lot of standard bodies that go into that as well. We're constantly maturing that particular piece. To the storage, centralized storage. There was a missing link inside of this whole ecosystem for quite a bit of time. We think we've made some partnerships inside of the industry to be able to actually bring that into fruition quite a bit more. And hopefully in sometime in the near future, you'll hear things that we come out with. Delivery of it. At the end of the day, we've built a robust set of APIs to connect all the 1D, 2D, 3D data together, and whether that's engineering, inspection data, projects data, all of our work orders, you name it, to bring extra context. So context, again, is another one of those games. To consumption, and really being able to look at this from two factors, not from the aspect of just technology alone and being able to consume via either your iPad, like this guy up here, or a headset, like an XR headset, or a tablet or a PC, or whether it's a remote engineer or a person in the field. That's one aspect of it, but actually the use case also drives a whole nother aspect of a workflow for consuming information and data, whether that's for training, or it's for design, or it's for engineering, or it's for inspection data, or it could be for emergency response. So this has actually been one of the key foundations that's helped us allow us to use that information, not just one time, but consume many times, which is, again, the name of the game, data management at scale.
Big, bold word on the bottom of that slide. You don't have to go back, because I know the animation is probably going to freeze it up. Many uses. We were oftentimes, back then, single use. Create that data, throw it away. Didn't really have a life cycle for it. Okay, so we just poured 10 years, 3 years of overview for you guys. Now that you understand, it's open and interoperable. We have a capture, store, deliver, consume, and a digital thread pillar to make sure that our data is ours and own, from what Kyle was talking about. And this is how we've been layering it. Capture, democratize, like he said. So we do point cloud, reality captures. We get 360 images as well, just like your Google Earth, Google Street Views, and things like that. We get UAV photos and create mesh models from them. In its simplest form, it gives us basic visualization. There's already value in dumb dimensional data for us to be there without being there.
To the next layer, like we mentioned before, connecting that 2D whether that's our sewer maps or firewater maps, blast zones, plot plans, you name it, bringing all of that into the same spatial plane. It sounds, like relatively simplistic, but being able to do that scale across the enterprise is a pretty large feat and actually extremely beneficial whenever I'm looking at things of, work orders and tying them to reality, or being able to label these assets from drawings that I already have versus actually having to use engineering resources to be able to do that.
Reduce that cognitive load, right?
There.
Overlay. Looks like we have a bit of an issue on the slide.
Hiccup.
Sorry about that, but you can kind of see, right? We capture it, we connect it, or we overlay it, and then technically we connect it here as well with 1D. What you see all those blue boxes they're highlighting over our reality captures are really our bounding boxes. That digital thread on how we create those relationships between 1, 2, and 3, that is completely monumental for us. And it's the reason why we have the digital thread. Kyle mentioned it already, at scale. It's been our mission. We have to do this globally across all of our sites. How do we convince plant managers to say, I need you to leave your platform if they've already invested hours of training and creating those relationships? We got to own that data. We got to understand our common denominator is location data. The geospatial data, that's where we build those relationships. So that's what we mean by connecting that 1D to 3D, and we're saving that in that digital thread.
To layering in all of the three-dimensional data that we have, whether it's CAD drawings of a tower or a furnace or whatever it would be, and layering it again to the same spatial plane. So I can see the internals of a particular asset, or be able to work in a project space and tie in brownfield assets to greenfield assets.
Cool. Going faster now, right? Create it, combine it, overlay it. This is what we do with it. So on the project side, what we combine, like mentioned, our CAD models as well as our reality capture. And moving to a visual way of working, red probably means requires some type of attention, whether there's no reality capture there and you only have your CAD. But you can also think about, well, what if we added time to that and you're off schedule? You're off tolerance. That's what we mean by moving to a visual of working. Instead of seeing this entire model and so forth, well, what are my problems I need to look at? And hone in on that visually.
To TA and planning, turnaround event planning, and the aspect of being able to bring in simple equipment, whether that's scaffolding or cranes, and drop it into reality, so I can see if I have clearance zones between areas. To taking all of the actual work list items for a turnaround and spatially mapping it into the world. So both my field operators and my remote engineers that are planning that event have access to the same information, and they know it's real because it is reality. To being able to lay out temporary piping inside of in the middle of an event, all right, or towards the beginning of an event whenever I'm planning for it. I might not need perfect accuracy on that piping, but I do need some type of visual to be able to have a conversation.
Enhanced visual inspection. I love this slide. We do captures at heights. We do captures internally, right? We create mesh models from these drone captured images, and we feed them into deep learning tools for visual inspection. So that way, those little yellow cuboids on the picture on my right, your left, I believe, right? It's just all the images of the drone captures. Those are the anomalies. Why would I care about everything else that looks fine? Show me the things that are wrong, like the corrosion, the missing insulation, right? The missing bolts and things like that. Same thing at heights. Do it for internal as well. That really leads us to iterate to, well, what if I was able to localize our operators out in the field with geo positioning systems, visual positioning systems, or indoor positioning systems? Starts unlocking a whole bunch of other abilities. One of our sites actually called it, you're giving us superpowers in a way with technology, right? Because I can be down here and see all the way up there with a device or headset, and I can see through my equipment if I need to.
And we're sharing some of these use cases. I want to kind of remind you, there are things that we need to figure out and scale in each one of these particular components. Some of them are already scalable, some of them are not. Immersive technology, the world of XR, we've done a lot of work within the training space over a period of time. It's actually some of the ground truth of what we worked on at the very beginning, and how we actually leverage the technology to help save lives, to design reviews of all of our facilities. So those are de facto things that we use XR for in the process of design, whether it's pre-feed or it's feed in a project, to the aspect of doing construction progress tracking. This one's an interesting one of us trying to figure out how do we actually allow people to do what we call will the couch fit, drop things into the reality while they're actually in reality. And doing at that scale right now is actually, there's some hiccups in how you actually do that and position yourself in reality. To connected worker, that aspect of just being there without being there, allowing our operators to talk to their SMEs that might be across the ocean, they might be in some other city or some other space.
And our last example of how we reuse our spatial data, augmented field procedures, right? Take that 3D asset, animate it, break down the procedures. It's really, how many people put IKEA furniture together and followed animations or pages and so forth, right? This is at scale and thousands of steps with high fidelity, right? But again, it just shows an example of how we are reusing that spatial data.
All right, we're going to take a little bit of time here to talk about what our vision is of reality first, and hopefully it'll start some good conversations. If you look at traditional twins back in the day, a lot of it was driven off of engineering CAD drawing. So you'd have engineering design happen, you'd tie data to that drawing or that model. And then you would ultimately shift all that data back out of the drawing or model and back into the engineering systems and operations. And if you looked at it from a lens of an ERP system, you'd see something like this, where the colored areas were areas that were tracked or in our ERP systems, and all the rest of it you wouldn't even see. You wouldn't understand that it even existed. And that's a problem, right, at the end of the day. And whenever you actually go out and look at reality, and this is a scan to 1/8 of an inch of that exact same area, I get more context instantly. So I've got context about where the fire monitors are, or where the railings are, right, in a particular area, or I get context of color and corrosion and all the things that I would get from a visual perspective. But then you start asking, okay, well, great, but you lose all the extra context of engineering information. And what our big proposition here is that it's not a competition between CAD and reality capture. It is a marry of the two, both in space and time. And so being able to tie all of our information back to a particular space is powerful. And that's what we're doing at scale right now through a large number of our assets. Taking all the CAD information out of a CAD model, taking all of the reality scans, meshing them together, and building out bounding boxes or spatial tags, or what we're calling them, to the real world. So I know that this is reality, or at least I know in some sense that this is reality at one point in time. I'll skip this part for time.
Okay. We're down to the final piece, the call to action. Own your data, but really, join this journey with us. Separate that data from software, right? This is not an ExxonMobil thing. There's a reason why we're out here. It's to influence and validate at the same time. If you've been locked in, if you've been on other journeys for monolithic stacks and things like that, that's why we're communicating out there the value of owning your data, the value of reality capture, the value of connecting that geospatially. Join this journey with us.
We're going to dive into two areas that we're working in industry. And there's a number of other ones. So again, we love joining industry consortiums to try to drive industry standards forward. One of the ones that we're actually working in is called the ARC Advisory Group, and they've pulled together a large number of our majors together to say, what is an open asset digital twin? And not only just say, what is it? Let's define and look at synergies across each of our companies of gaps that we need to cover. So there's been a long journey since the inception of this particular work effort in 2020 to 2024. I won't go into a crazy amount of detail, but we're synergistic in quite a number of spaces. If you look across our industry, we agree in the aspect of reality capture and trying to drive that forward. We agree in the ability to be able to make P&IDs more interoperable. What is a smart P&ID is a question that constantly comes up and is worked on. So super encourage you guys to look at the aspect of this open asset digital twin. And what we did in that is we actually pulled together, I think, 216 companies. There might be more now, not just from owner-operators, but from the EPC companies, our engineering and procurement companies, and our suppliers, and look and asked the whole group, what are some of the things preventing digital twin adoption at scale? And it was actually funny, it was relatively unanimous that the cost of creating and maintaining is really large. There's a lack of expertise both from the process modeling side and from the 3D side, poor and inaccurate data quality, and on, which you guys can probably see why we're driving some of these industry conversations as much as we possibly can, because we need the cost of ownership to go down to be able to get to scale at massive scale.
But wait, there's
you should
more.
probably take a screenshot of that. That's a survey that you can help fill out and get into it. It also will give you the contact information for that open asset digital twin.
And we're also part of the Digital Twin Consortium as well, right? We don't know what we know. We know only so much. And so we're out there talking to other adjacent industries, and Digital Twin Consortium is a great channel for that. Just look at the breadth of the landscape. And this is probably an outdated slide. There's probably a lot more folks that have joined since then. But wanted to give a huge shout out to them. And if you scroll to the next slide for me, Kyle, that capabilities periodic table, scan that QR code. It's free out there. We urge everybody just to take a look. Look at those capabilities out there, because then really helps you really socialize exactly what capabilities your solutions are offering or what you're shopping for. And folks, from the overview to how we've layered that spatial data, to us reusing that data for the various use cases, we've compiled a video for 2024 that we want to share with the audience here. I hope this works, because I only had a few seconds to set up the audio.
Let's just see. Let's click it.
So we're going to... Nope, didn't work. Hang on for a second. Give us a second to check on the audio jack, and then from there we'll play that video.
Are you guys getting audio on your side? Speaker.
I thought it picked the headphones. So. And check if the volume is on too, Kyle, for the PowerPoint slide. I guess in the meantime, while he's figuring that out, are there any questions from the audience? Yes, sir. Hey, Kurt.
I got a mic for you. Hold on one second.
I'm going to pull the mic and we'll play
So
the video.
I'm Kurt Schuringer from Amazon Web Services. I think you've done a great job, actually, of also showing your data strategy, something I don't think we've seen at some of these conferences at all. We see a lot of use cases. We see a lot, how does this affect only the headsets? But I think showing the full pipeline of how you get your data
100%.
through this whole process is quite powerful. One of the questions that I have for you is, as part of your DRE system, do you see that as your primary source of truth system? Are you still connecting and integrating with other source of truth systems? And what does that look like a little bit as part of that?
Oh, that's a great question. So yeah, right now, there is no source of truth for spatial and visual data inside of our company. There's some work efforts in the pipeline world that'll help from the spatial side. But it is a constant, it's an evolving journey of us creating a ground truth for all of that spatial and visual data. So yes, it is. The connections and ties to other systems, there's sources of record and systems of record for those as well. So it is, what we're showing on stage is like way less than 1/3 of a component of the entire work effort that we're trying to do beyond even Dre, and how we actually create and elevate data across the whole pipeline. That's a great question.
Kurt, we actually had that slide and removed it due to time. So we were just going to talk about that piece too. But thanks for bringing it up.
Maybe I can unplug it and just put my mic
Yeah,
up
let's do it.
against
Let's
Yeah.
do it the old school way
Does that
then.
work? Is it okay if I just throw the mic towards it?
Yeah, let's go for it.
Yeah.
Okay,
Innovation.
we're gonna do it. We're gonna rig it.
Yeah, I got it. All right. No worries.
Kyle's gonna hold the microphone up to the speaker. Hopefully you guys can hear it. There's no words anyways.
From laser scanning to virtual reality, 3D models and other digital data captures are quickly becoming must-have technologies in our industry. Globally, ExxonMobil has spent tremendous resources on independent 3D efforts, from capture to creation, and even purchased visual assets. These 3D models help us gain better insights, make informed decisions, visualize disparate data, and streamline innovation. However, many of our 3D assets are stored in various locations and used locally when they could be leveraged across ExxonMobil facilities. As part of a company-wide initiative, we're establishing a digital reality ecosystem, which will serve as a foundation for our 3D visual assets platform. This ecosystem will help us capture 3D models in formats that everyone can use, centralize where they are stored, and automate the way they are delivered, so they can be used by anyone, at any time, from anywhere. This ecosystem will allow us to move toward a more visual way of working with contextualized data, which will be essential to our success for corporate scale and integration, now and in the future.
folks. Hopefully that was helpful. This is a QR code for myself and Em. What we want to leave you with is Exxon has moved to a visual way of working, and we need the industry to help keep pushing it along.
Thank you for your time. AES, thank you for the opportunity.
Great job, guys. Kurt, great question. Kyle, the way you held the mic at the end was amazing.